One of the things that I loved about what Issam talked about was collaboration, and I think that a great example of a new style of collaboration is our next speaker, Stephen Friend. Stephen began his career as a pediatric oncologist, and then shortly after, he founded a technology that would better identify genes in diseased tissues that new drugs could be aimed at. And it was Rosetta, and that eventually was sold to Merck. And then he was with Merck for a number of years, but recently founded and is now president of Sage Bionetworks. And the incredible thing about this nonprofit is that it crowdsources solutions, so now all people can participate in what has traditionally been closed-door research. He believes that science should not be confined to a lab, and he wants to hear any and all ideas that might spark more innovation. So, Stephen.
I want to talk about the power of curiosity. I want to talk about how people can assess themselves. But to start, I want you to think about the following. Quantitation, ability to quantify things. When I arrived at the airport this morning, I could open up my iPhone and I could pull up an app and I could pretty confidently figure out a way to get here. And the point here is quantitative assessment enabling our lives from technology. Similarly, if I had to figure out whether or not I was going to need to bring a coat or not, I could get on, and all that power of knowing where the moisture is, how to figure out where the rain is seamlessly integrated into some parts of our life. In medicine, over the last century, there have begun to be significant inroads into doing that type of quantification. If you look at the impact of radiology, ability to say whether someone's bone is fractured or not, we take that for granted. Similarly, in infectious disease, when you walk in and someone has a sore throat, the ability for medicine to go in and say, is this strep throat? What is the sequence of the entire organism? That's coming along. And some areas, such as cardiovascular disease or diabetes or asthma, this has been moving along. But what I want to focus on today is a broad swath of medicine that's been left behind, and it has to do with syndromes. So a good segment of medicine, more than you might realize, tens of millions of people in the US, hundreds of millions of people in the world at a minimum. When they go to a doctor, the doctor looks at symptoms. And those symptoms define what they have, not only what they have, but what drug they're going to be given, and when you're running trials, actually how that trial is going to go on. So examples that you probably know about, there are abundant, and they're usually named after some astute clinician who figured out, this is really these sets of patients that have something in common. Now here comes the fallacy. I and many others thought that genomic information would sort of like thrash this, turn it into a way of doing precision medicine. But the reality is that most of these grab bags of all these patients might or might not have something is really mucking up the ability to give patients what they need. So let's just take one of these, Parkinson's disease. This is James. James in 1817 in London was smart enough to figure out these were the symptoms that occur in Parkinson's disease. And to this day, when you go in, it's in the cranium of a local physician or neurologist that someone goes, aha, this is what you have. It usually takes years to get to that. And the number of failed trials, we could go on and on and on. Imagine a world where we had a way to actually have quantitative assessments of those syndromes. What it would allow you to do, and this is what we dream of, and that's why I started with that picture of the GPS map at the beginning, is imagine how powerful it would be to have on our phone a way of tracking whether we were going in or out of disease. Whether in fact, whether we ate triple cheeseburger or had too much wine or we exercised, actually we could tell what that did to each one of our risks for diseases. To do that, and that's slightly fanciful, but I don't think too much, we need to fundamentally change how we assess diseases, how we approach trying to define them. And the solution sits there around us to the extent that pervasive computing devices at about 1 billion across the world seem to be plenty of opportunities. So we have this theme, which is N, which is number of patients you would need. You can certainly get that there. Frequency that you'd actually assess a patient, not twice a year in a physician's office, but maybe continually. Time. D, dimensions of data. How many dimensions? Instead of saying fatigue, how many dimensions could you get out? And then M, having it machine readable. And we think that the power that comes from having smartphones can be basically harnessed to be able to pull that off. 3 years ago, Robert Wood Johnson Foundation and DARPA funded us to take on a pretty audacious project, which was, let's assume that most clinical trials are done as if they are in medieval age, where the person is a, quote, subject. Why don't we flip it and make it so that actually people were equal partners to the researchers? Where it was participant-centered trials, where actually people yearned to be in trials because they could understand themselves, they could work with others. So we began to figure out how could you have a dialogue instead of Hoover vacuum cleaner sucking up people's data. Imagine a dialogue going on while you're in the trial, what's working, what's not. And so in March of this year, with a very fortunate partnership with Apple, when they launched ResearchKit, Sage Bionetworks built out 2 of the ResearchKit apps. I'm going to talk about one of these because I think it can tell the story well, which is we went back and said, James, maybe we could have it so that instead of people being seen twice a year, maybe we could have it so that they had a way to do exactly what a physician was doing anytime they want to assess themselves. So Empower is the app. You can download it from the App Store. Here are all the consultants that we have helping us. And what we did, which is essential if you're going to do any type of innovation, is we went back and said, who's got the closest thing? So it was the philanthropy behind Andy Grove and what he did at Intel and Kinetics, a sort of clunky device. There were about 150 of these, and we said, is that something we can leverage? So we leveraged that and built out this Empower app where an individual can sit there and follow the tapping the way a neurologist could, look at phonation and how their voice comes, 1,000 dimensions of data that we can get off of that. We can go and look at how someone walks and how they stand up and their balance. We can go ahead and measure people's memory. Kate Posen at UCSF helped us with that, and a number of other things that you can go look up. Since the launch in March, we saw a remarkable thing. A lot of people downloaded the app, but a good fraction of those had Parkinson, were controls, and within weeks we had more individuals in that trial than had ever been enrolled. It was not costly to do that because people are curious. They want to be engaged. And so one example of data, which is, here's a 62-year-old man, this is 60 days of data, and every time before and after they take a medicine, they are tracking, not we, they are tracking how their disease is. And those arrows are improvements when they go up and not doing as well when they take their drug. That chaotic picture is reality in many diseases. We're looking at it in Parkinson's disease, and you could look at it in many other diseases. That's what people have going on. But the really cool thing, and I think